Hi there, it's me, Mr. B. Let's solve quadratics using the factoring method. Okay, so the example I'm going to work through is I want to find the roots for x squared plus 3x equals 10. So let's just go back and review a little bit that roots is just another word for zeros. So I can say find the zeros. I could say find the x-intercepts. I could say find the solutions. And the roots as well. So any of those terms I can use to find where the graph crosses the x-axis. All right, so I want to find the roots for x squared plus 3x equals 10. So step number one, I want to write the equation in standard forms. Standard form is setting the equation equal to 0, but I want to write it in a certain way, and that certain way is I want to write ax squared plus bx plus c equals 0. The x squared term has a coefficient of a, the x term has a coefficient of b, and the c is the constant. Now they're not always going to be positive, but I want to write it in that order. So the highest exponent of x first, then the next highest, then the least highest, which is the constant. All right, so the first thing I need to do here is I want to subtract 10 from both sides. Now, there's no like terms to combine. I'm just going to stick the minus 10 on the end of the equation. So I'm going to end up with x squared plus 3x minus 10 equals 0. Now, I will point out a little word of advice here. You always want to keep your x squared term positive. It's not a requirement, but it makes the factoring a lot easier. Most of the time when we factor, the x squared term, that first leading coefficient, is going to be positive, and that makes the factoring a lot easier. Because if it's negative, then it just introduces another negative sign into the factoring, and that's just a lot more difficult. So let's just keep the x squared positive. We can move things around to keep the x squared positive. All right, second step, factor it. So in this case, I'm going to do trial and error. I have 3 terms. So I'm going to look for 2 numbers that add or that multiply to give me negative 10, that add or subtract to give me positive 3. So I make my parentheses, put my x at the beginning of each quantity, and it looks like it's going to be 5 and 2. So in order to get a positive 3, I want plus 5 minus 2. Okay, so I want to set each factor equal to 0 and solve, because if either one of these things, if x plus 5 is equal to 0, so let's say x is negative 5, negative 5 plus 5 is 0. It doesn't matter what's over here because I'm taking this whole thing, which is 0, times this thing, which is going to give me 0. So I want to see what makes each of these factors, what's in the parentheses, each of these factors equal to 0, makes them equal to 0. All right, so let's go ahead and take x plus 5 and set it equal to 0. And solve the little equation, so I'm going to subtract 5 from both sides, so x equals negative 5. Then I'm going to take x minus 2, set it equal to 0, solve it, so add 2 to both sides, x equals 2. So those are my solutions, and I can check them by just plugging back into the original equation. Negative 5 squared is 25. 3 times negative 5 is negative 15, so 25 minus 15 is 10. It works. 2 squared is 4. 3 times 2 is 6, so 4 plus 6 is 10. It works. Those are my zeros, my roots, solutions, x-intercepts. Hi there, it's me, Mr. B. Let's find the solution for x squared plus 7 equals 8x. Again, solution set, roots, zeros, x-intercepts, they all mean the same thing. So the first step is write this equation in the standard form. Okay, so I want to get everything on one side equal sign, 0 on the other. So let's try and keep our x squared term positive. It already is in this case, so I'm going to subtract 8x from both sides. So that's going to give me x squared minus 8x plus 7 equals 0. Second step, factor. Okay, again, I have a trial and error problem here. I can't do GCF. Remember, always start with GCF, but I can't do GCF. There's nothing in common in all 3 of those terms. So now I just go to trial and error. So I'm looking for 2 numbers that multiply to give me 7, that add or subtract to give me 8, negative 8. And that, of course, is going to be 7 and 1. So in order to get a negative 8, I'm going to do minus 7, minus 1. Those are my 2 factors. So I want to set each of those factors equal to 0. So x minus 7 equals 0. So add 7 to both sides. X equals 7. And I say x minus 1 equals 0. X equals 1. Now you might be saying, well, can't I just change the sign on the negative 7 and negative 1 to just positive 7, positive 1? Yes, you can. The problem is, what happens when there's a coefficient in front of the x? For instance, let's say I have 2x minus 1 as one of my factors. I'm just kind of doing this separate from the problem here. I want to set that equal to 0. 2x minus 1 equals 0. Now the problem is, if I just say it's 1, the answer is not 1. 2 times 1 is 2, minus 1 is not 0, it's 1. So what I have to do here is add 1, divide by 2, x equals 1/2. So I can just switch the sign on that constant there, the negative 7 and negative 1, only if the coefficient in front of the x is a 1. If it's anything other than a 1, then I actually have to solve the equation. Hi there, let's find the x-intercepts for 5x squared equals 20x. I want to write this in standard form, so I want to subtract 20x from both sides. Now you'll notice that there's no constant here, and that's okay. I'm going to still write it in standard form. So 5x squared, put the x squared term first, minus 20x equals 0. Let's go ahead and factor it. It looks like there's a 5 and an x in common in each of those terms. So 5x, if I take a 5 and an x out of the first term, I have an x left. If I take a 5 and an x out of the second term, divided by 5x, I'm left with a 4. Alright, so those are my factors. It looks like it's factored completely. This is a very important concept right here. That right there is a factor. 5x is a factor. If it was just a 5, let's say it looked like this, 5 times x minus 4, this would not be a factor. This would be a factor, but the 5 is not a factor because there's no variable attached to it. Okay, so now I want to set each of my factors equal to 0 and solve it. Alright, so 5x equals 0. Solve for x, that means I'm going to divide by 5. 0 divided by 5 is just 0. So x equals 0. Now I go x minus 4 equals 0. Add 4 to both sides, x equals 4. And there are my two solutions. If you plug them back in up top, they're going to work. 5 times 0 squared is 0. 20 times 0 is 0. 0 equals 0. That works. Take a 4. 4 squared is 16. 16 times 5 is 80. 4 times 20 is 80. I got 80 on both sides. That works. So there's my two solutions. All right, let's find zeros for 2x squared equals negative 3x plus 14. I want to write it in standard form first. So I have a positive x squared on the left-hand side. Even though I have two terms on the right-hand side, it's actually better to keep the x squared positive. So I'm going to move the negative 3x and the 14 over to the other side of the equation. So I want to add 3x and subtract 14. All right, so let's write it in standard form. So 2x squared plus 3x. Remember, write the squared term first, then the x term, then the constant, equals 0. Alright, so I can't do GCF, so now I'm going to try something else. There's 3 terms, and my leading coefficient is bigger than 1, so let's try slide and divide. So I'm going to slide the 2 over to the 14, so x squared plus 3x, 2 times 14 is 28. Alright, so let's go ahead and do this using the regular old trial and error way. So it looks like 7 and 4 are going to be my numbers. So in order to get a positive 3, I want to do positive 7, negative 4. At this point, I need to bring that 2 back in for the divide part of the slide and divide. So I'm going to do 7 divided by 2, 4 divided by 2. So that's going to eventually give me, I can't reduce 7 halves, so I'm going to slide the 2 back over in front of the x. So 2x plus 7. And 4 divided by 2 is 2, so x minus 2. Alright, so I'm now done factoring. Let's set those factors equal to 0. 2x plus 7 equals 0. Okay, I cannot just say my answer is negative 7 because that 2 right there, it's bigger than a 1. Alright, so I have to solve it. So I'm going to subtract 7 from both sides. So I have 2x equals negative 7. divide by 2, so x equals negative 7/2. Let's set our other factor equal to 0. X minus 2 equals 0. Add 2 to both sides. X equals 2. And there are my solutions. The next method of solving quadratics is the graphing method. And the graphing method only has 2 steps. And we're going to be primarily using Desmos to find the roots or zeros or solutions of a quadratic equation. You can do this in the calculator, but it's a little more difficult. It's a lot easier using Desmos. All right, so we're going to find the solutions for the equation x squared minus 5x equals 24. Now, the first thing you want to do, just like solving any quadratic equation, is to put the equation into standard form. So I'm going to go ahead and subtract 24 from both sides. So I end up with x squared minus 5x minus 24 equals 0. Okay, so I'm going to go ahead and show you how to do this in Desmos, but before I do that, I just want to point out the 2 steps here. I want to type the standard form equation into Desmos without the equal 0 part. So I'm going to leave this part off when I go ahead and type that into Desmos. And I'll explain why when I show you Desmos. And then once I see the graph, I can just click on the points where it crosses the x-axis, and those will be the solutions. Okay, so let's go ahead and look at Desmos. Okay, so I'm at Desmos, and I'm going to go ahead and find the roots, solutions, zeros, solution set. They all mean the same thing, but it's basically where the graph crosses the x-axis. For x squared minus 5x minus 24. All right, so notice I didn't add the equal 0 part to that because I put it in standard form, but I cut off the equal 0. If I put the equal 0 in there, notice how the graph changes. It's not actually the curve. It's not actually the quadratic graph, the parabola, the U shape that I'm looking for. It doesn't look like that. Zoom out, I can see the U. If I put the equal 0 there, it completely changes the graph. It's not actually the graph, it's just 2 parallel lines. So I'm going to do that. Now, the other way to do it, if you really wanted to, is to say equals y. That will work. But you do not want to put the equal 0. It's just easier to just leave it off and just leave it in standard form. All right, so let's go home. And I can see my 2 roots right here. There's the Desmos actually finds them for me. It puts dots on them for me. So if I click on the graph, and I click on those dots right there, and I click on the graph if the dots aren't there. So right now the dots aren't there. If I just click on the graph, the dots show up, and there's one there, and there's one there, and those are my 2 roots. They're my answers, my solutions. So -3 and +8. You can write -3, 0 in parentheses and 8, 0 in parentheses. That's fine. Or you can just write -3, 8, but do not put parentheses around that because it then becomes a point. But my answers here are -3 and 8.